Hi guys, we're going to start day 4, which is on function notation, so let's go ahead and get started. First we have to do our vocab, which is independent variable, here, is a variable that provides input values of a function, so it's our x values, and dependent variable is a variable that provides the output values of a function, the y values. Now let's use function notation, which is just another fancy way of writing part of an equation for a function. So function notation is right here, f of x, an f and then an x in parentheses. What this is representing is the output value. So when you see f of x, that is your y value, okay? It represents our y, and we read it as f of x, okay? Because this is the result we're going to get when we plug in a certain x into a function. So this will tell us our input value, and f of x, the whole thing, will tell us our output value. Okay? So example 1, we're going to make a table for the function, and all of our functions today is going to be equations. So we're not going to see a whole lot of visual stuff. We'll see the algebraic way today. So we have to determine the range given this function, the equation, and its domain. So we're going to make a table for it. So first I'm going to take the domain and plug it into my table, into the x values, because domain is x. Now what I'm going to do is I'm going to take each individual x and plug it into the equation for x and simplify it to figure out what y equals. So 0 times 5 will give me 0, so y equals 0. 1 times 5 will give me 5, so y equals 5. 2 times 5 gives me 10, so y equals 10. And 3 times 5 will give me 15, so y equals 15. Now that I filled in my y column, I have my range. So I can just go ahead and write it. 0, 5, 10, and 15. Okay? I need to have this up. Now you guys are going to try this on your own. You can either pause the video or come back to it. It's up to you. Okay? This next part isn't really, I don't know what, it's kind of ish. So when we talk about an equation for a function, it's most of the time it's going to make a line, okay? And the way that we can graph this is we're going to make a table. It's very similar to how we already did it. And let's see what happens. So we have our equation, x plus 1, and this f of x here just means this is going to equal our y. So you could even cross f of x out and just put a y over it if you don't like this whole thing. But it just means y, it just means your output value. So we're going to put our inputs, our x's, in for x. So negative 1 plus 1 gives me 0. 0 plus 1 gives me 1. 1 plus 1 gives me 2. 2 plus 1 gives me 3. So those are my y values, which means they're going to make my points. I'm just going to move this off to the side because I don't need this right now. So what I'm going to do now is plot these points on the graph. Okay? So I've got negative 1, 0, 0, 1, 1, 2, and 2, 3. Okay? Now that I have these points, what would happen if I connected the points? Well, they would make a line, just like this. Okay? And that line, every time we have a connected line like this, it means all these ordered pairs that are on this line are part of this function. So, even though I only plugged in 4 numbers, there's actually lots more x's that I can do. Okay, and I can extend this table and I can put a whole lot more, and they would all be on this line. So, to answer the next question, is it a relation? Yeah, because it's a bunch of ordered pairs. Is it a function? Well, will it pass the vertical line test? Yeah, so it's a function. Okay, example 2, given the range, find the domain of the function. So, last time we were given the domain and we just plugged in for x and filled in our y's. Now we're given the y values, or the f of x values. So what we're going to do is we're going to plug in each of these values in for f of x and solve for x. So, oh goodness. Alright, where's the other one? There we go. That's what I want to start with. So I'm going to first plug in negative 9 for the f of x part. So I replace the entire part. So it's negative 9 equals 1 half x minus 8. So now I just solve for x. Add 8, I get negative 1 equals 1/2 x, multiply by 2, multiply by 2. I get x equals negative 2, so I fill that in my table. Then I plug in negative 8.5, plug that in. I'm going to add 8 to both sides, so I get negative 0.5 equals 1/2, multiply by 2, multiply by 2, where'd it go? I get negative 1 equals x, so I plug that in. Then I do it for negative 8, I think it's over here, yeah. Plug in negative 8 for f of x. Add 8, I get 0 equals 1/2 x, multiply by 2, multiply by 2, x equals 0. There we go. Do it for the last one. Where'd it go? Where'd it go? Oh, there's something. There's something. Oh no, I think it's not there anymore, which is so much fun. That's there. Alright, well my equation's gone, but it should just be negative 7 equals 1/2 x minus 8. Okay, then I would add 8 to both sides, and I get 1 equals 1/2 x times 2 times 2, which the times 2 part is gone, but I get x equals 2. And there we go. Okay? So now that will give me my domain. I just have to rewrite them. Did I write it out? I have no idea anymore. So my domain is, I'll write it right now, D is brace negative 2, negative 1, 0, 1. Oh, not 1, 2. And close the brace. This is my domain. And I should make sure I write it out. Okay? Now you guys are going to try these two on your own. These are a lot easier than what I just did. Okay? And you can pause the video or come back to it. It's up to you. Alright, some more vocab. An x-intercept is the point where a graph crosses the x-axis, where a y-intercept is the point where the graph crosses the y-axis. How do we write these? Well, as ordered pairs, we have x-intercepts are written as x, comma 0. So x-intercept should always have a value, a number for x, and the y will always be 0. For y-intercepts, you always have a 0 for x and a value for y. Okay? Some synonyms for x-intercepts, because they go by lots of different names. Solutions, you'll hear. Zeros, you'll hear. Roots, those are all synonyms for only x-intercepts. Okay? Only for x-intercepts. Alright? So example 3, given the following graphs, what are the intercepts? So x and y. Whenever you see the word intercepts, you are writing it as an ordered pair. So I'm just going to write this underneath, comma. There we go. Whenever you see the word intercepts, you write it as an ordered pair. Alright? And then it's asking, is the graph a function? So if I look at this graph, I have to look for an x-intercept first. So I look at the x-axis. This guy is crossing right here, and that number is at negative 7. So the x value is negative 7, the y value is 0. So I just write it as an ordered pair, which doesn't want to show up now. So it's negative 7, comma, 0 is my x-intercept. Okay? By y-intercept, I look at the y-axis. It's crossing right here at 6. So that is my y-intercept. I write it as 0. Nothing wants to show up when I do it. Comma, 6. Y value always goes on the back. Okay? And that is my y-intercept. Now, is it a function? Well, if I do my vertical line test, I only cross it once. So yes, it is a function. Okay? All this stuff doesn't want to show up. Okay, so I want you to ignore this thing. Cross it out. Bleh, don't like it. Don't like it. And I want you to use the equation 6x. Oh gosh, I don't remember what it is. Hold on. 6x minus 7y equals negative 42. Let's use this. Okay? This is the equation for this line. Okay? But if I wasn't given the graph and I was only given the equation, I would still be asked to find the intercepts. It's just going to be a little bit harder. Okay? So for the x-intercepts, I will struggle a lot. Okay? What I'm going to do is, to find the x-intercept, I plug in 0 for the y. Okay? And then I solve for the x value. So I have 6x minus 7 times 0 equals negative 42. Equals negative 42. It's going to be a little bit longer because my computer's not working for me. Okay. Then this part will disappear because it's just going to equal 0. I don't like it, so I'm going to get rid of it. So now I have 6x equals negative 42. I'll move it in 2 seconds. There you go. And now I can just go ahead and solve for x. So divide by 6, divide by 6. I get x equals negative 7. So my x-intercept, I'm going to write it over here, is negative 7, comma 0. Just like what I got graphically. This is my final answer. For the y-intercept, I just plug in 0, but for the x this time. Okay? And 0 for x. There we go. Okay? So basically, whichever intercept I have, I'm going to plug in the 0 for the other one. Okay? So I have 6 times 0 minus 7y equals negative 42. So now I'm just going to go ahead and solve. Well, this part will disappear. And so what I get is negative 7y equals negative 42. And I go ahead and solve for it. So I take my marker. I'm going to divide by negative 7. Divide by negative 7. And I get y equals 6. So I use that y value to make my intercept ordered pair. So 0, comma 6. Just like we got from the graph. Okay? So now you guys are going to try a graph on your own. And then what you're going to do is you're going to try an equation on your own as well. Okay? So give those two a try. You can either pause the video or come back to it at the end. Example 4, given the graph, what are the zeros? Why did we put all this extra stuff in here? So zeros are not the same thing as x-intercepts, okay? So I'm actually going to make you ignore this part. So take your marker or whatever and get rid of this. We don't want it. I'm going to make it disappear. Watch, it's fun. Make it disappear. Okay? And what we're going to do is find the zeros. Now, hopefully you were paying attention when we did the notes. Zeros is another name for x-intercepts. Okay? So that is what we're looking for. It's just the x-intercepts. Now, we write them a little bit differently. Okay? We just write them as x equals the number. Okay? That's how we write a zero. It's different than an intercept. With intercepts we write as ordered pairs, zeros we just write as x equals the number. So what we are going to do is we're going to look for the x-intercepts on the graph, and it's okay if there's more than one. I'm going to put a little star on it. How about that? Yeah. And I think there's going to be more than one, so I'm going to copy it. You guys can see the inner workings of what I do. It's so much fun. Paste. Alright, so I made 2 stars because I think there's more than one. So I'm going to look for the x-intercepts. So I look at the x-axis and I'm crossing here. So I'm going to put a little star right there. And I'm also crossing here. Okay? Those are my x-intercepts. So those values are what x equals. Those are the zeros. Okay? So we would write it for the zeros, we would just write x equals -1, and for the other one, we're just going to do a comma, it equals 3. X equals -1 and 3. You could put, instead of a comma, you could put and, because there's only 2. Alright? Those are our zeros. Where it's just asking, when it's asking for zeros, they're just asking for the x-intercept, and you write it just as the numbers. Now, is this a function? We can do the vertical line test, and we find out, yes, it is. Okay? So last little bit, you guys are going to try this one on your own. And again, this is what I want you to do. I want you to cross out all this, because we don't need the intercepts for this part. So you can ignore it, get rid of it, whatever you need to do. Of course, it didn't want to do it when I did that. Wait and wait. And you are just going to write zeros equal, and then tell me what it equals. Okay? Alright, and then is it a function or not? Answer that question. Okay? That's it for the video. If you have any questions, or write them down, I will answer them next class. Okay? Bye!